All right, course 3, here we go. Lesson 31. Adding integers and collecting like terms. Ooh, adding integers. You remember what integers are, right? We're talking positive and negative numbers here. So get to do some really fun stuff today. If you think of integers as I'm writing this down, think of integers like temperature, like Fahrenheit. Because when we are, losing my train of thought, when we are doing scales, you know, like in the winter when it, you know, coming up, when it's 10 degrees below zero out, you don't want to go outside and the sun comes out and we get up to like a really warm 5 degrees above zero, that's a 15-degree difference. That's the kind of stuff that we're going to be doing today. So it'll be really helpful for you to do that. So, for example, let's take that example and let's run with that. It's -4 when you get up in the morning. That's cold. Not as cold as it has been, but that's cold. And later on in the day, that we find out that it is 6 degrees when we go out to recess. So yay, we get to go out to recess. It's above zero. What's the temperature difference? Well, it's a 10-degree difference between -4 and 6. If you wanted to prove that, you could draw it out on the number line. You could graph it out. You could graph this puppy out. Okay, we start here, and we go all the way to here, and you could count that. All right, so what that does for us is that gives us that 10-degree difference that we're looking at. Because from -4 to 6 is 10 degrees, 10 spots on the number line. All right, and that's exactly what we are going to do. So we can prove lots of stuff. So I'm going to draw one number line, and I'm going to use this number line 3 different times. You can do the same thing in your notebooks. And I'm going to indicate my different problems with different colors. I'm going to go up to 7 on both sides. Don't worry if your tick marks aren't quite even. Mine certainly aren't. So let's do a couple of them. Let's do the first one in red. Let's do A. -3 plus +5 equals +2. So the proof of that is if we start with -3 here and +5, oh, and we add 5 to it, I'm thinking. We add 5 to it. All right, so I got interrupted. I had a call, so let's take a look at this. So we start with -3, and we want to indicate where things go with this. If I add 5 to my number, if I add 5, then I'm going to go 5 over. So -2, -1, 0, 1, 2, and then that ends up at 2. So I got a distance separation of +5 on those numbers. So I can indicate that by going up this way, then going up this way, going 5 over to end up at 2. Now, like I said, I'm going to do this in different colors so you can see all the different ones. So let's try B. B says +3 plus -5 equals -2. All right, so like this time we're going to start ... I'm going to go all the way over to +3. Okay, went to +3. And then I'm going to go 5 backwards. We'll go way up here to get all the way. Okay, I'm going to go 5 backwards, so 3 over, and then 2 more. Okay, my answer is -2. One more to kind of indicate my point. -5 plus -3 equals -8. Now this time I'm going to write this below it so we can see this third one. So this time I would start again at 0, go to -5. That's my starting ground. And now my answer, now I'm going to add another -3. So I'm going to continue my journey to the left. And so that means I'm going to go down and then over 3 more. And to do that, I actually need to write in another tick mark. I should have gone all the way out to 8, shouldn't I? So let's put my colors back. So my answer is 8. So now I got -8, I should say, because I'm on the negative side of things. So there you go. So we can really do those things. So take a look at A and B. Take a look at those two. Do those add-ins have the same signs or opposite signs? The answer is opposite. Okay, they have opposite signs. Because they have opposite signs, you can see that we end up going opposite directions from our 0. We go one way and then we end up backtracking the other way. But notice C. Notice C is 2 negative numbers, so we continue in the same direction. So what that means for you is we can determine the sign of the sum of negative and positive numbers by which one is the greater one, the greater absolute value. So in this case, right here, the greatest absolute value is 5. So our answer is +2. And we subtract 5 minus 3 to get 2. Now in this case, the greatest absolute value, it happens to be this one, and that's -5. So so 5 minus 3 is 2, so that answer is a negative number, so we end up with -2. So we can graduate away from doing number lines to just find the sums. So let's try a few of these. -6 plus +2. All right, those are opposite signs. The 6 has the greatest absolute value, so 6 minus 2 is 4, and because the greatest absolute value was a negative number, it's -6. +6 plus -2, let's fix my 6 because I'm sloppy. That equals, now the greatest absolute value is positive, so I'm going to have a positive number. 6 minus 2 is 4, so I can leave it as 4. -6 plus -2. They're both negative numbers, so my answer is going to be a negative number. And because they're both negative numbers, I add them. 6 plus 2 is 8. And finally, -6 plus +6. These are total opposites. They're exact same distance away from 0, so they both have the same absolute value. So in this case, the answer is 0. So that's very helpful. Okay, and of course, this is something that we can remember, something we've done before, the additive inverse. Hopefully you can still read that. I didn't leave myself enough room. We can change any subtraction problem into an addition problem by adding the opposite of the subtrahend. All right, so we can do that by doing this. This is algebra here. Okay, so 6 minus 2, something you're used to, but we could change it to a positive number by doing this. 6 plus -2 equals 4. And this is how you write a problem algebraically. So there are some rules to help you out for addition with 2 integers. The rules are this. 1, subtract the absolute value of the add-ins. 2, take the sign of the add-in with the greater absolute value. And of course, this is when you have the sum with different signs. Now, when the signs are the same, I'm going to change my color. when the signs are the same, we have to do a few different things. When the signs are the same, we have to do something a little bit different. We're going to add the absolute values to the addends. So step one, add the absolute value of the addends. And then we are going to take the sign of the addends. So whatever the addends is, that's what we're going to do. All right? So let's move on to our next thing. And that is collecting like terms. There's a couple of things that you need to keep in mind. The word term is an algebraic expression that includes a positive or negative number and may include variables. So lots of stuff going on here. May include variables. So for example, we have 3y as a term, x negative w squared, 3x squared y negative 2. Okay, and the other thing is to know is something called the numerical coefficient. Numerical coefficient, or just the coefficient for short, and in this case, that is the 3. In this case, with x, the coefficient here is actually 1, even though the 1 is not drawn in, it's invisible. The coefficient of this one is -1. The coefficient of this one is 3. And that we don't, a term without a variable like this one, -2, is not a coefficient, that's called a constant. So keep that in mind. So what that means for us is we can simplify problems by collecting like terms. Okay, so we could do 3x plus 2 minus x plus 3 by adding the things that are the same. The things that are the same in this problem are 3x and -x and +2 and +3. Okay, it's not the numerical coefficients we're looking at, we're looking at the variables, and the constants are just constants. So what that problem means is 3x minus x is 2x, because remember that my numerical coefficient there is 1. And then 2 plus 3 is +5, so 2x plus 5. My problem is simplified. I don't have simplified, so I don't have to do anything, and that's called combining like terms. Kind of a useful trick for us to do, is we can combine like terms. And what that means is we're doing the commutative property of addition to solve those problems. So one final thing is I got a rectangle drawn here, 3 and 2x, and the perimeter of the rectangle is P equals 2L plus 2W. So let's write this out. P equals 2 times 3 plus 2x plus 2x, because that's 2x times 2, or the same thing. So that could give us P equals 4x plus 6. And I like to write my expressions with the variable up front. So try practice A through N on page 207 for your homework. Thank you. Have a good night.